Hello and welcome to the SynthVR crash course. This video is for those of you who may not be too familiar with modular synthesizers, but you've downloaded SynthVR and you just want to jump in and make some cool sounds. What is a modular synthesizer? A synthesizer is a machine that generates sound. It synthesizes sound. There's some processes, it sends data to a speaker, the speaker vibrates, that goes into your ear and your brain goes, "Ooh, there's a sound." Modular means we can build the synthesizer using its core bits and pieces, or its modules. We can arrange them in any way, we can flip them around, we can connect them in bizarre, weird ways, and then create our own unique monster that makes sound. We can create our own synthesizer using the basic modules. And that's what we're going to be exploring today. We're going to look at what SynthVR offers us as modules, and we're going to connect them in a very straightforward way. By the end of the video, you'll have an understanding of how the process works, how the signal flows, and how you can actually start experimenting and connecting things in different ways to create your own unique stuff. So I'm going to grab my menu panel here and I'm going to drag it just somewhere which is nice and easily accessible. I'm going to go into the Create tab. This is where all of our modules live. We have different categories down the left here, and it may look like there's not many modules, but remember we can have multiple copies of these and we can connect them in all kinds of different ways, so there's actually a lot going on here. I'm going to stick with the Audio Sources tab. I'm going to click on the speaker, and this says the speaker plays a spatialized sound from a single input. Basically, this is your endpoint. So if I create a speaker here and drag it up over onto the right, anything that goes into this green socket, this green input hole, is going to become audible in our headset or in our speakers. This is our endpoint. Let's talk about our start point. I'm going to go over here to the left. On the left-hand side, this is where the sound starts. With synthesis, it's usually an oscillator. So an oscillator takes a particular shape, like a sine wave or a square wave, and it repeats it over and over and over. Sounds really simple, but it does it so fast that it starts creating a tone. So it can go thousands of times per second, tens of thousands of times per second. The faster it goes, the higher the pitch. So let's go ahead and create an oscillator. I'm going to go back here. I'm going to stay in our Audio Sources tab. I'm going to click on the Lab Osc, which is the very first option, and let's go Create. I'm going to drag this over to the left-hand side. You'll see that we have 3 dials, an input and an output. I'm going to take the output, click, or I'm going to hover over the output and click. I'm going to drag it all the way to the input of the speaker and let go. And now we can hear a tone. So we can hear a sine wave here. It's a nice rounded pure tone. It's a very plain, very simple tone, but we now have an oscillator repeating itself over and over and over. It's going so fast, the speaker is vibrating, and we're registering that as a tone. Now looking at the oscillator, we have one big dial here. This is the freak or frequency or the pitch. So I talked before about it going really slowly and really fast. As I click on this and drag it to the right or clockwise, you'll hear the pitch going up. So it's getting faster and faster and faster and faster. And as I bring it down, the oscillations slow down, and they slow all the way down to the point where they're inaudible. So we can't actually hear these. The speaker can't produce them. It's going so slow we don't hear anything. But let's bring it back up to its default value here, or a little bit higher. Now we have another dial here, which is amp. You can think of this as amplify or volume. So by bringing this down, the volume goes away. By bringing it back up to normal, we can hear it again, or we can boost it if we want. But I'm going to bring that back down to its default. Instead of using this amp, I'm going to go ahead and create a new module. I'm going to go into my audio modifiers, and I'm going to create a lab amp. So it's basically a module that does the amp function, but it has more things that we can do. So I'm going to hold my index finger on this for a second, and it will pop out for me. Let's drag that up next to the speaker. I'm going to take this cable here by clicking on the green input, and I'm going to move it to the input of the amp. So I went from the speaker to the amp instead. Now this is going into this, and you can instantly see the display starts showing us the waveform. If I was to bring the level up, you'll see the waveform gets bigger. That means it's louder, and as I bring it down, the waveform will shrink to nothing. Let's bring the level back up to the middle position here, or roughly, and I'm going to take the output of the amp and feed that into the speaker. And now we can hear the tone just like we did before. So again, the oscillator is generating the sound. That's coming through to the lab amp. The lab amp is sending it to the speaker. 3 modules, 2 connections. I'm just going to grab this lab osc and move it over here. We can move things around anywhere we like. I'm just going to move it here for now because I want to bring the frequency down, and I want you to look at the waveform display, because you'll be able to see as I slow down, it gets slower and slower and slower, to the point where we can actually see the individual oscillations. There's one, there's another, and so on. So this is inaudible, but as we speed it up, it gets faster and faster. we can start hearing things. Okay, let's grab this and put it back over here because this is where the sound starts. Now, it's all fun playing with the frequency here, but let's get something a bit more interactive. I'm going to go into our control sources tab and use this lab val. So let's click on that and hold it with our index finger, drag it over here next to the lab osc. So what does this do? This is interesting. We have a pink ball, and I can click and grab this with my index finger, and then I can move it around anywhere in our environment. And I can walk around or teleport around, and I can carry this with me. You'll see that this has 6 outputs, 1, 2, 3, 4, 5, 6. These correspond to the position of the ball in space. So we have Y, which is up and down, we have X, which is left and right, and we have Z, which is forward and back. So how do we use these with the lab osc? I'll let go of the ball, it springs back. You'll see we have one input here. This input is a CV in. So a CV means control voltage. It's a fancy way of saying an information signal. So this signal here, which is the output into the amp, this is an actual audio signal. We can hear this. If we were to look at the waveform inside of this cable or imagine it, it's something that we can actually hear with our ears. Whereas the CV input or a signal between devices that send CV, they're telling it to do something. It's information. So you can think of it as an informational signal rather than an audible signal. Now, when I move this up, you'll see that the Y here lights up. As I bring it up, it lights up. So what I'm going to do is I'm going to connect the output of the Y into the CV in. I'm saying I want this to control this. And in the lab osc, the CV in controls the frequency. I need to say how much I want it to control it. So I'm going to turn the CV amount all the way up. And now when I grab the pink ball, as I move it up, the pitch goes up. Way too much fun. Okay, so that's all good. We've covered the control voltage and we've covered audio signals. Let's change the sine wave to something a little bit more complicated and start getting some exciting sounds. So what I'm going to do is I'm going to use my middle finger and grab this, and I'm going to push the A button. Then I'm going to let go of both of them and it's gone away. Let's go back to our audio sources, and instead of the lab osc, I'm going to choose the prime wave. So I'm going to hold down, here it is. It's a lot more, well, it's a bit more complicated than the simple oscillator we had, but in theory, it's the same thing. It just gives us some more options. So you might notice that there's 3 outputs on this. The red means output. We have A plus B, and B. That's because this oscillator has 2 vibrating signals. We have A, which is going at one speed, B, which can be going at another. They can be different shapes. They're independent of each other, but we can actually mix them together. Let's not focus on that for a second. I'm just going to bring the mix value all the way to the right. That's just saying I want to focus on the waveform on the right, or waveform number 2. And this is the B waveform. I should say waveform number B. Now, if I connect the B output into the amp like before, we can hear the sine wave. Let's bring the coarse value up, which is the frequency. Let's bring the amp up a bit more. Actually, I need to turn it up on my headphones. I don't want to blow your guys' ears out. Okay, so at the moment, we just have a sine wave. If I click on this button, however, you can see the sine wave there. It's nice and smooth. This is what you're hearing thousands of times per second over and over and over. If I click on this, we can cycle through different waveforms that are far more exciting. So this is a triangle. You'll see how it has slightly sharper points where it bounces back. You can think of your speaker actually pushing it, sucking in, and then when it's at its innermost point, it's pushing out, and then it gets to its outermost point, and then it sucks back in again. It repeats this over and over. So with the triangle, it's a little bit more sharp, but if we click it again, we get a square. Let's actually turn that down, turn the level down, right down. So a square is incredibly sharp. The speaker is sucked in and then it's suddenly pushed out. Boom. So this is where we start getting the really sharp, harsh sounds. Let's cycle again. This is a saw wave, and this is probably the most, well, the funnest one for me to use. And we have all kinds of different shapes here. Let's just cycle through them until we get back to our sine. A few more. Let's get back to the saw wave, and let's bring that down. And if we look up here, we can kind of see that the lab amp is showing us a more saw wave type pattern. Okay, that's all good, but what else can we add in this chain of events? We've still only got an oscillator, an amp, and a speaker. Well, let's go back into our audio modifiers and create a prime filter. So I'm going to click and drag on this. I'm going to drag this up next to the prime wave. Now I'm going to take this connection and I'm going to bring it into the input of the filter. So we're taking it from the lab amp into the filter. If you accidentally let go, the connection goes away. It doesn't matter. We can still connect it again by just hovering over the B output. Remember, this is the one that we used. Going into the input of the filter, and then the output is right here. Let's grab that and let's send that into the amp. Now you'll notice there's a bit of a difference in the sound. It sounds more dull or kind of compressed, if you like. So what the filter does is it filters out frequencies. So you specify a particular frequency with this big dial, and in its current state, anything above the frequency on this dial, so anything above this particular point, it's going to be gone. It's going to cut it off. It's called a cutoff filter. It will cut all those frequencies but let everything in below it through. So at the moment this is set to, I don't know, about 75%. If I was to click and open this up, all the way, all the frequencies are coming through of the square wave, saw wave. If I was to click on this and bring it down, now we're only hearing a very small amount. If we go all the way down here and bring the frequency down, all we're going to be able to hear is the bass. We're not going to be able to hear those high excited tones, but we can bring it up again. We can bring it up and down. Lots of fun to play with. Now, the other important thing to know about a filter is the resonance. So these two are your main go-tos for a filter. The frequency defines the frequency where it's cut off. The resonance will boost that frequency. It will give it a little bit of amplification, and the more that you have, the more defined the frequency point of cutoff is. So if I was to bring the resonance up, you'll actually see the shape here change. You'll see that we're giving it a bit of a tip, a bit of a point. Now when I move this, you're going to hear a much sharper sound. This is with no resonance. It's quite bland. This is with quite a lot of resonance. And you can actually really bring this up, sometimes too high. That's how you get those acid sounds if you want them. So that's a good thing to think about. I'm going to bring the resonance down to about halfway. Now let's talk about controlling this. So you'll see that we actually have two control voltage inputs here. This says freq CVA and freq CVB. So this means this control voltage will alter the frequency, this fun one to play with. So instead of turning this dial, I can connect something into the CV. So let's go ahead and do what we did before. I'm going to take the Y output here, and I'm going to put this into the freq CV. Let's turn the CV amount up, and let's start playing with the ball. See, as I move the ball up, the frequency is going up. Let's change the frequency down so it's quite low. This is relative to where we set this. So if I grab the ball now, a lot of fun. So that's all I'm going to cover on the filter. There are quite a lot of other things. We can change the type so it lets through frequencies just in the high end, all kinds of other things. We can add some drive, we can add another CV in amount, but let's not get too far. I just want to cover the basics here. So going back to this pink ball, actually let's open this up a little bit. So this is up and down. Let's talk about left and right. So let's go right. You'll see that the X plus lights up when I move it right. So let's connect that into the pitch. This is the CV in for the pitch of the oscillator. So now we have up and down controlling this frequency, and we have left and right controlling the pitch. So as I move it this way, you hear the pitch going up. Let's bring the level up a bit. I'm going to have to adjust these post-production, I think, but you guys won't notice, and that statement was irrelevant. So let's bring it to the right again. Now let's bring it up and down. Now let's do both. A lot of fun. Okay, so that's the basic concept of a filter. Let's go ahead and do something a little bit different. So this is good if you want to play with something, okay? But I'm going to get rid of this. I'm just going to nuke it by pushing the A button and it's gone. I want to create some melody. I want to create a sequence of sounds, so something that's rhythmical and melodic. So let's go into our sequencing tab and choose a lab sequencer. Let's drag it up above the waveform here, and let's have a look at what we've got. We have 8 sliders up here and we have 8 buttons here. These sliders are important. Each one of these has a particular value, and that value comes out of the value output. So I'm going to take the value output and put it into the pitch of the oscillator input of pitch. So these correspond to this pitch, but what we can do is set different values and then we can cycle through each one. Let me just open up this prime filter for you and turn it down a little bit on the level. Okay, so let's say we want to cycle through them. Well, how can we do that? We need something to generate rhythm. Well, fortunately, we have a lab clock. So I'm going to click on this, drag it up next to the sequencer. This is pretty straightforward. We have a speed and a clock output. Don't worry about the mod stuff. We just have speed and clock output. So I'm going to take the output of the clock, which is continuously sending a tick, and I'm going to put that into the clock here. And you'll see that suddenly we have movement. We have a red light moving across these faders here. Now, if I was to move these faders around, you'll see that we're sending a different pitch value into this oscillator. We can move these around in any way that we want. We can speed up the clock with the speed value here. This will make the ticks faster and the sequencer faster. Let's bring it down again. And just to show you how control voltages, how powerful they are, instead of connecting it to the pitch, let's put it into the frequency of the filter. And let's bring this down. I'm going to bring this down just so we can see. You'll see how each one of these corresponds to the frequency opening up. Very cool. But for now, I want to keep this on the pitch, so I'm going to get rid of this connection and I'm going to connect it back into the pitch and open up the frequency. But it doesn't sound melodically rich. It doesn't sound in key. That's a problem because it's just sending random values and they're not actual notes. We can get around this by, first I'll disconnect this. I'm going to go into our control modifiers and I'm going to choose a lab note. I'm going to put this next to my sequencer. I'm going to connect the value out of this into this, and now I'm going to connect the output of the same line that I connected the input into the pitch. So we've introduced this between the sequencer and the prime wave. Let's bring these down a bit. And you'll hear this is now in key. It's in a minor key. So this takes the values that are being sent from the sequencer, it goes, oh, these aren't quite matching, it makes them match and then sends them out. So it kind of conditions the signal for us so that we do actually get a nice melodic pitch going on. Very cool. Okay, let's say I want to move that around slowly. What can we do here? Well, remember before when we had the original oscillator, the original very simple sine wave, I'm going to use that to actually control the filter because control signals don't have to be small values such as a sequencer or whatever. We can actually use an oscillator here. I'm going to put it below the filter and I'm going to make it incredibly slow, super slow. Remember this was showing us a waveform before that was going about once every second or so. I'm going to take the output of this oscillator and instead of listening to it, instead of actually putting it into the speaker so we can hear it, I'm going to put it into this frequency CV input. So this is now going to modulate the filter for us. You can see the speed of that oscillator, which once was used for audio, is now controlling the frequency. If I bring the frequency down, we can speed it up with the frequency dial. Let's bring it up a little bit. Let's make it faster. We could actually start going so fast it might generate its own unique sound. Let's try. Very good. Okay, I'm happy with that. The last thing I'm going to add is let's put in an effect. And currently there's only one, but it's a good one. It's the prime space. It's a reverb. So I'm going to click and hold that, and I'm going to go and put this next to our filter. I'm going to take the output of the filter, which is currently going into the amp, and instead I'm going to have that going into the left of this prime space. So you'll notice that the prime space or the reverb has two inputs, a left and a right, and it has two outputs, a left and a right. This is a slight problem because we only have one output from our filter. So I'm going to introduce one more thing in connection mods. I don't want to spam you with too much, but if you scroll all the way to the right, there's a very simple but very handy device, especially if you're new, called a splitter. And you can probably gather what this does. It will take the signal that you feed into it, so in this case the output of the filter, and then we can split it 4 different ways. So now I can split that single signal into 2. We have one output here into the left, one output here, which is the right. Very good. Now I need to take the outputs and feed them to the speaker, but the speaker only has one output. So what do we do about this? Well, I'm going to get rid of the speaker, I'm going to get rid of the amp, and I'm going to go ahead and create an audio, under the audio sources category, a lab out. So just again, the speakers you can put around, you can have multiple speakers if you like, but I'm going to choose the lab out, which is basically a straight stereo left and right output. So if you don't want to hear the sound changing as you move around your environment, we can just use this lab output. Very simple, left and right. Let's drag it up here. Let's connect the output of the left of the reverb into the left input of the out, and the right into the right. You can now hear that we have the reverb affecting the sound. I can make the reverb much bigger by changing the size. I can change the mix, so when I have this all the way down, we don't hear any reverb. We can get just a little bit. We can have a lot. We can have only reverb. Let's just have it about halfway. I'm going to change the frequency of this down slower. Let's bring the CV amount down a little bit so it only wobbles just a little bit. You can see as I bring this down, it starts getting smaller and smaller. But let's bring this up. Let's make it even slower. That's as slow as it goes. Let's bring the lab clock down. And let's bring the prime wave down. More size. And now we can have a jam. Let's change the waveform. A nice bell one. Let's go to this other waveform on the other side. Let's choose a different one, maybe that one. And now if we move the mix, it'll start morphing them together. We need the output to come from A and B combined here. What we could do, one last thing, this is always how the end of my videos go. What we could do is we could grab a splitter like I did before in the connection mods. Let's add this next to the sequencer. So the value is actually going into a splitter. We're sending it to the note, so this is sending it to the oscillator to generate the notes. But I also want the value of this to go into the waveform mix. So you can see we have a mod input here. So I can take the sequencer value and send it here as well. Let's do some extreme changes. And you can see this mix is now moving. Each one of these values is changing the waveform. Let's change these around. And I'm going to leave it there. Thanks for tuning in. Again, this is for the Alpha 0.6.2. There may have been an update since you've watched this, so check the description below. Make sure you check out the SynthVR Discord, a really nice bunch of people that communicate and share ideas all the time. And I hope you got something from this video. My name's Tom Cosm. Have a good day.